Hi, my name is Michael. I'm 32 years old and I'm working in the field of computer science and support in the automotive and other embedded industries to get more computer capacity in the devices. In my project and with our company, we support in the automotive industry and other industries to get more computation capacities in embedded devices and improve the software which is running on these processors. In many industries where now multi-core processors are used, the software now has to run in parallel where it was intentionally not designed for. So we improve here the architecture of the software and enable to run the software more efficiently and also to reduce blocking in the software, which allows finally a performance increase.
Before I show you what is behind this logo or this picture, I want to ask you a question. What do you think have all these four devices in common? Maybe you think they are white. Yes. Okay. No, but this is only on the surface. What is really inside and you don't see are these devices. So inside a car, for example, you have around 100 processor units which control this car. Currently, we have a trend in this kind of systems. They migrate and switch to a new processor technology, which will rapidly change the computation power which is in these devices and will then make it so intelligent we cannot imagine right now. What I focus with my work is how to enable this processing capacity for the software which is running on the devices. But why is this so important? It's one very, in my opinion, one of the most innovative minds of the world, which is Ray Kurzweil. In the year 2005, he published a work which is aligned to the work of Amdahl's law. And the year 2005, which he published in a book which is called The Singularity is Near. In this book, or in this, his experiments, he collected data from the last century, how computation power increases over the time. And quite interestingly, he compared how the computation capacity, which is available for $1,000, matches to the brain power of biological beings. By today, we achieve for $1,000 the brain power of one insect, which is not as much. By the year 2035, for $1,000, we will have in one processor the brain capacity of a human, and by the year 2045, we will have for $1,000 the brain capacity of the complete mankind. So this is amazing when the trends really show it goes in this direction. In the nature, this brain power or this computation power is achieved by a highly parallel organ, where billions of instructions and computation steps are executed in parallel. In the processors, we see currently a similar trend. So we have here now not only one processing unit, but multiple ones. So this is multi-core, and this is a many-core architecture. So we have really a parallel processing of instructions. But the problem to achieve this more computation capacity is not in the hardware, but is in the software which is running on these devices. The problem is the software is organized in different tasks and they are all dependent on each other. And the problem is when the software now should run in parallel, it really has to be carefully designed in a way they don't block each other. So meaning the timing is critical. In order to analyze and improve this software mapping to these processors, I developed in my research study at the Technical University Munich and together with Continental Automotive together an approach which simplifies this processor hardware and as well the tasks, so the software which are running on this processor, in a way it's possible to virtually, in a simulation, analyze this timing behavior and see how a current mapping of software on the hardware behaves. The benefit of this approach is not only you can run it in a virtual environment, but also you can run multiple of different software allocations to the processor in parallel and can compare each other to them and then see what is the best allocation of the software. So this is the first step. In the second step, this approach is combined with evolutional algorithms. So by analogy of genetic recombination, different solutions are combined or different software allocations are combined in order to improve in an iterative way better software allocations. As a result, there is something like an architecture or an execution plan how the software should run on these multi-core devices. And now is the result of this picture. So what we provide is the TA tool suite, which allows now not only to see the internal interconnection between the software, but also to see the timing behavior and also see how different software allocations work like. And as a result, the software is nicely structured, so it's easier to get an overview, and additionally the different tasks interact in a harmonic way, like the different musicians of an orchestra, for example. Yeah, what is the benefit of this approach? So this technology now can use to develop and to implement new features and functionalities, for example, in the automotive industry. So as we see here, for example, in the area of autonomous driving, it's now possible with the software and this new multi-core, many-core processors to process multiple sensor data like radar, camera, or ultrasonic and combine them and create a visual picture of the environment. So this is what will be already available in the next 5 years around, and maybe when we look more in the future, then it will also enable to have for the software enough computation power to achieve also humanoid robots, and having the computation power to create robots which are able to enter environments where humans are currently not able to go. And because this topic excites me and also fears me a bit at the same time, I decided in the year 2011 to found, together with my research colleague Martin Hobelsberger, a company called Timing Architects. We started here with 2 folding chairs and 2 tables and 2 notebooks. And by today, I'm quite proud to work with a creative team of around 30 engineers and support here the automotive industry and the automotive manufacturers, as already told, to develop the new generation of cars. Thank you.